Picture this. You are a shepherd somewhere in the ancient world. You have a small flock of sheep. They are fluffy, stubborn, and probably smell like, well, sheep. Every morning you lead them out to the fields. Every evening you bring them back. And here's the problem. If you bring back fewer sheep than you took out, you're not just in trouble with your boss. You might actually be in trouble with the gods. Because back then, people didn't just count sheep to stay awake at night. Counting sheep was literally tied to religion, rituals, and sacrifices. Numbers were sacred. They were a language between humans and the divine. And if you messed it up, well, imagine showing up at the temple with 9 sheep when Zeus had been promised 10. That's not a conversation you want to have with an angry thunder god. This is where math really begins. Not in fancy libraries or in long books filled with symbols, but in dirt fields, in clay tablets, and in the nervous heart of a shepherd praying not to miscount. Early humans discovered pretty quickly that counting mattered. It wasn't just a neat trick to brag about. It was survival, it was order, and it was a way of showing respect to whatever invisible power you believed ruled the world. Think about it. If you lived 4,000 or 5,000 years ago, nature must have looked terrifying. Thunder, lightning, earthquakes, the Nile flooding, crops failing, eclipses turning day into night. You had no science textbook to explain any of it. You had gods who apparently needed goats, sheep, grain, or maybe even the occasional unlucky human to stay happy. So counting became holy. If you promised the gods 12 jars of beer, you had to make sure it was 12, not 11. If you dedicated 7 cows to the harvest goddess, you'd better not misplace one along the way. Otherwise, maybe your harvest would fail, or your neighbor's hut would mysteriously burn down, and people would say, "Ah yes, the goddess noticed your little math mistake." In fact, numbers themselves often felt divine. Some cultures treated numbers as if they had personalities, moods, even cosmic power. The number 3 was almost always sacred. The number 7, pure magic. 12 showed up everywhere, from the 12 Olympian gods to the 12 months in a year. Counting wasn't just practical, it was spiritual. Let's make it even funnier. Imagine the stress of being the poor assistant at a temple in Mesopotamia, where people were lining up with offerings. 1 goat, 2 goats, 3 goats, and then, wait, did I say 3 already? You count again, and the goat moves, and you lose track, and now you're terrified that instead of blessing the city, the gods are going to unleash plagues because of your clumsy counting. This wasn't just paranoia. Ancient rituals were often incredibly strict about numbers. In Vedic India, if you were building a fire altar, the exact number of bricks had to match cosmic patterns. Miss 1 brick, and your entire sacrifice was invalid. The math mattered as much as the prayer, so priests, temple workers, and scribes started keeping careful track of numbers. They carved them into bones, stones, and later clay tablets. That's where math really started to take on a life of its own. The funny thing is, humans weren't naturally good at keeping track of large numbers. Our brains can instantly recognize 1, 2, 3, maybe 4 objects. Anything above that, and we need help. That's why the first counting tools weren't calculators or even abacuses. They were pebbles, knots in a rope, scratches on bones. Archaeologists have found tally sticks that are tens of thousands of years old, marks carved into bones, probably by someone keeping track of animals, food, or maybe debts. You can almost picture some ancient accountant saying, "Look, I'm not going to remember how many cows you owe me, so let's scratch it here on this stick." And suddenly, math is born out of distrust and divine fear. Now, what's really fascinating is how numbers quickly started to drift from simple counting to symbols of cosmic truth. The Babylonians, for example, believed their gods controlled the heavens, but then they noticed something strange. The moon, the stars, the planets, they followed patterns. The heavens weren't random tantrums of divine beings. They were predictable. You could count them, you could chart them, you could even say, hey, the moon will vanish in an eclipse on this exact date, which of course made the priests look extremely powerful, because suddenly they weren't just whispering prayers to the gods, they were predicting the gods' next moves. But let's not get ahead of ourselves. At this stage, counting was still wrapped in superstition. Numbers weren't thought of as human inventions. They were gifts from the gods themselves. In Egyptian mythology, for example, the god Thoth was credited with inventing writing, numbers, and all measurement. In Greek mythology, the 9 muses were responsible for inspiring knowledge, including math. And in Mesopotamia, Every number had a kind of magical personality. The gods didn't just rule over thunder and crops, they ruled over arithmetic too. Here's a little anecdote I love. The number 7 was so sacred in Mesopotamia that if a city had 7 gates, that was a divine design. 7 planets visible to the naked eye, 7 days of the week, 7 gods in the highest pantheon, and if something bad happened on the 7th day, you could blame the universe itself. Imagine living in a world where every Friday was basically sorry, the number 7 is in a bad mood today. At the same time, these sacred numbers had very practical uses. Farmers needed calendars, kings needed to know how much tax to collect, temples needed to keep track of sacrifices, so the scribes who were supposedly recording divine numbers were also doing very earthly bookkeeping. And in that mix of spirituality and practicality, math started to grow roots. So when we say counting sheep for the gods, we're not joking. People literally believed that miscounting could make or break their fate. But in the background, something bigger was happening. Every time someone tallied goats, jars of grain, or bricks for a temple, they were also training their brain to see patterns. And patterns, once noticed, have a way of growing. Patterns are dangerous to myths, because once you see that the Nile floods in a cycle, or that the moon disappears on schedule, you start asking a dangerous question. Wait, is this really the gods at work, or is it just math? And that's where the story begins. Math, born from sheep, sacrifices and fear, slowly starts to sharpen its teeth, first as a servant to the gods, then, quietly, as a challenger. The battlefield of myths and numbers is about to open. Let's play a little game. I'll say a number, and you say the first thing that comes to mind. Ready? 3. Most people will say triangle, Trinity, or maybe the 3 Musketeers. Now 7, lucky number 7. Maybe 7 days of the week, 7 wonders of the world, or 7 dwarves, if you grew up with fairy tales. How about 12? 12 months, 12 hours on the clock, 12 apostles, 12 signs of the zodiac. What you just did in your head is the same thing humans have been doing for thousands of years, treating some numbers as special, as magical, as if they carry a secret meaning beyond just 1 more than 6. Numbers were not always just about quantity. In many cultures, they were symbols of divine order. They had power. People believed the universe was not random, but built from numbers, and some numbers carried more weight than others. Let's start with 3. Why 3? Because it's the smallest number that can form a shape. With 2 points, you only get a line. With 3, you get a triangle. Suddenly you have stability, balance, a little mini-universe of geometry. So 3 became sacred, holy trinities, triple goddesses, 3-headed guardians at the gates of the underworld. If you wanted a number that felt complete, 3 was it. Then we moved to 7. Oh, 7, the rock star of numbers. In Mesopotamia, there were 7 visible planets in the sky, so 7 gods ruling over them. In Judaism and Christianity, God creates the world in 6 days and rests on the 7th. In ancient China, 7 represented the harmony of yin and yang, with the 5 elements. Across cultures, 7 kept popping up like a cosmic Easter egg. You couldn't escape it. 7 was considered lucky, magical, mysterious. If something important happened, you'd better check if the number 7 was involved. And then 12. 12 is the organizer, the planner, the accountant of the cosmos. There are 12 lunar cycles in a year, so 12 months, 12 hours of daylight, 12 of night. The Greeks had 12 major Olympian gods. Christianity had 12 apostles. Even today, our entire system of timekeeping and calendars basically bows down to 12. There's something about 12 that screams order. It's like the universe's way of saying, don't worry, I've got this scheduled. But here's the funny part. People didn't always agree on which numbers were magical. In Egypt, for instance, the number 2 was super important, symbolizing duality, life and death, order and chaos, the Nile's 2 banks. The Mayans, who had their own number system, thought 13 was deeply sacred. In some Native American traditions, 4 was the divine number, tied to the 4 directions. So it wasn't just about math. It was about culture, geography, and what people noticed in their everyday lives. Still, certain numbers seemed to grab everyone's imagination. And this wasn't just harmless superstition. Sacred numbers shaped how people built their temples, wrote their myths, even structured their societies. For example, in Babylon, the The ziggurat, those giant step temples, were often built with 7 levels, each one representing a planet and its ruling god. Walk up those stairs, and you are literally climbing through the universe, one sacred number at a time. In Egypt, the pyramids were not just tombs, they were cosmic calculators. The number of sides, the slope of the angles, the orientation toward the stars, all tied to sacred proportions. The Egyptians weren't just stacking stones, they were building the afterlife with math. And yes, if you're wondering, they definitely believed that messing up the numbers could mess up eternity. Imagine being the unlucky builder who sneezed and measured a block wrong. Sorry, Pharaoh, you're trapped in the wrong dimension forever because I cut this stone at 44.9 degrees instead of 45. No pressure. Now here's where things get fascinating. Sacred numbers were not only used for temples and rituals, they also crept into everyday life. Farmers planted according to numerological calendars, merchants priced goods using lucky numbers, even healers prescribed treatments based on sacred counts. In some traditions, chanting a prayer 3 times was considered more powerful than once. In others, walking around a sacred object 7 times guaranteed protection. The numbers themselves became medicine, magic, and law. And yet underneath all the mysticism, something else was happening. People started noticing that these sacred numbers also worked in very practical ways. 12 months wasn't just a religious symbol, it was a pretty good approximation for tracking the solar year. 7 days wasn't just mystical, it divided the lunar month nicely. 3 wasn't only holy, it was the minimal stable shape in geometry. Slowly, the magical numbers revealed a secret. They weren't just divine, they were mathematical. Let me tell you a little story about Pythagoras. Yes, the same Pythagoras you suffered through in school with his a squared plus b squared equals c squared. Long before that theorem haunted your homework, Pythagoras ran what was basically a math cult in ancient Greece. His followers treated numbers as sacred truths. They weren't just obsessed with math, they worshipped it. They believed the universe itself was built on number harmony. And they especially loved certain ratios like 2.1, 3.2, 4.3, which showed up in musical notes. To them, music was proof that math and the divine were the same thing. The lyre string didn't just make a sound, it revealed cosmic order. Of course, this obsession sometimes got weird. The Pythagoreans had strict rules, like not eating beans. Nobody's quite sure why. Maybe they thought beans contained souls. Maybe beans gave them bad gas. Either way, this mix of math, mysticism, and odd rituals shows how numbers straddled the line between sacred and practical. And it wasn't just the Greeks. In India, the concept of 0, eventually the most powerful number of all, was first tied to the void, the cosmic nothingness, a spiritual idea before it became a mathematical one. In China, odd and even numbers were linked to yin and yang. Everywhere you look, numbers weren't just tools, they were identities, gods in disguise. But here's the twist. Once people treated numbers as sacred, they started collecting them, testing them, organizing them. The very act of reverence led to curiosity, and curiosity led to mathematics. If the number 7 is divine, let's track where it appears. If 12 is holy, let's divide the year into 12ths. If 3 is perfect, let's build triangles and see what happens. In chasing the magic of numbers, people accidentally stumbled into science. And that is the great irony. By treating numbers as supernatural, humans were slowly disarming the gods. Because sooner or later, someone was going to say, wait, what if the numbers aren't sacred at all? What if they're just rules of the universe? What if we don't need angry gods throwing thunderbolts to explain anything? What if we just need math? So sacred numbers were the bridge. They began as myth and ended as logic. They gave comfort, order, and mystery. But they also opened the door to skepticism. Once you start seeing patterns, it's hard to stop. And once you stop, it's even harder to believe that your sheep died because the number 7 was in a bad mood. The gods still had their temples, the priests still chanted their rituals, but somewhere scribes and philosophers were beginning to whisper, maybe it's not the gods running the show, maybe it's the numbers. Imagine standing in front of the Great Pyramid of Giza. It's hot, the sun is glaring, and you're just a tiny speck staring up at 2.5 million blocks of stone stacked into a perfect triangle, pointing at the sky. You don't need to be a mathematician to feel something strange in that moment. Because the pyramids are not just big piles of rocks. They are geometry made physical. They are math turned into architecture. And here's the kicker. The people who built them weren't thinking, "Oh yes, let's solve a fun equation today." No, they believed they were building eternal stairways for the souls of kings. They believed geometry wasn't just about lines and angles. It was about eternity, the afterlife and the will of the gods. This is one of the most fascinating things about ancient math. It didn't start in classrooms. It started in temples. Math was religion's construction crew. The gods demanded shrines, tombs, ziggurats, cathedrals. Humans delivered, and the delivery invoice was paid in numbers. Let's take Egypt first. The pyramids are probably the most famous example of sacred geometry. Every slope, every angle, every alignment had meaning. The Great Pyramid is almost perfectly aligned with the cardinal directions north, south, east, west. The error margin is so small it would impress a modern surveyor with lasers, and yet the Egyptians did this over 4,000 years ago, using ropes, poles, and a lot of clever thinking. But it wasn't just about precision, it was about symbolism. The pyramid shape itself, broad at the bottom, sharp at the top, was a way of reaching from Earth toward the heavens. It was like a frozen sunbeam, a staircase for the pharaoh's soul to climb into eternity. And the numbers inside the pyramid were just as sacred. The slope angle of the Great Pyramid has been connected to the golden ratio, to pi, to star alignments. Whether or not the Egyptians consciously used those numbers, one thing is clear: geometry was their way of talking to the universe. Now let's travel a little east, to Mesopotamia. Here the temples look different. Instead of smooth-sided pyramids, they built ziggurats. These were massive step-shaped towers like giant wedding cakes of mud brick. Each level was dedicated to a god, and climbing the stairs was a spiritual journey. Again, geometry and religion blended. A ziggurat wasn't just a building, it was a diagram of the cosmos. The gods lived up high, humans down low, and the temple itself was the bridge between the two. And you know what's hilarious? Imagine being the poor guy in charge of building these things. No calculators, no cranes, no modern tools, just a boss who says, "Hey, the gods demand a giant mountain made of stone. Oh, and by the way, it must be perfectly aligned with the stars, or else talk about workplace pressure." But somehow they pulled it off. And in doing so, they created the first marriage of math and architecture. You can almost imagine the builders starting with string stretched tight between two stakes, drawing straight lines in the sand, measuring angles with shadows. Little by little, geometry was born, not from abstract thinking, but from bricks, stones, and divine deadlines. Now let's zoom out. Across cultures, the same thing kept happening. Religion wanted grand, eternal monuments. Math provided the tools. In Greece, temples like the Parthenon were built with breathtaking proportions. The architects used ratios to make the columns look perfectly straight, even though they actually bulged slightly in the middle. Why? Because human eyes play tricks. Straight lines can look curved, so the Greeks used geometry to fool your brain into seeing divine perfection. That's math working hand in hand with psychology, 2,000 years before Instagram filters. In India, temple builders used elaborate geometric grids called mandalas as blueprints. The idea was that the temple wasn't just a house for the gods, it was the cosmos itself in miniature. Every measurement had symbolic meaning. Every ratio mirrored some cosmic truth. Walk into a Hindu temple, and you're not just stepping into a building, you're stepping into math disguised as stone. The Mayans in Central America did the same. Their pyramids were often aligned with the sun so that on the equinox, shadows would create patterns of a serpent slithering down the steps. Imagine standing there watching a giant snake of shadow crawl down a temple wall. That wasn't just spectacle, that was math convincing you the gods were real. And here's the punchline. The builders probably didn't even separate math from religion. For them, measuring the angle of a shadow wasn't science. It was worship. Drawing a perfect circle in sand wasn't geometry homework. It was sacred ritual. Math and myth were the same language, just spoken in different accents. Now, were these people perfect mathematicians? No. There's a lot of debate over whether they really used pi or the golden ratio, or whether we modern folks are just projecting our obsessions onto their work. Maybe the Great Pyramid's slope angle matches pi by coincidence. Maybe it was just a practical solution for stacking blocks. But here's what matters: even if they didn't consciously calculate these numbers, they still stumbled into them. By trying to please the gods, they bumped straight into universal mathematical truths. Let me give you an example. Suppose you want to build a giant pyramid with stable sides. You experiment with different slopes, too steep and the stones slide off, too shallow and it looks squat and unimpressive. Eventually you find the sweet spot, the angle that both works structurally and looks majestic. Congratulations, you've just discovered a ratio that modern mathematicians will argue about for centuries. That's the beauty of it. Math hides inside the universe, whether you know it or not. Build something big enough, precise enough, and you'll find math waiting for you like an old friend. And here's where it gets even more interesting. Once humans mastered geometry for temples and pyramids, they didn't stop. They used the same skills for practical stuff. Measuring farmland, dividing property, planning cities. Sacred geometry quietly became useful geometry. The gods might have demanded pyramids, but the farmers demanded field boundaries, and both jobs required math. So let's zoom back in. Imagine an ancient Egyptian priest standing proudly before a newly finished pyramid. He sees a divine staircase for the pharaoh's soul, a symbol of eternity. The builders see aching backs, sunburn, and probably a few missing fingers, and hidden in all of it is math, humming quietly in the background. Lines, angles, ratios, numbers doing their thing whether the people realized it or not. And that's the story of early geometry. It didn't fall from the sky as abstract theory. It rose from the ground, brick by brick, stone by stone, temple by temple. At first it served the gods, but in the process it gave humans something much bigger, a taste of power. Because once you can measure the land, build monuments, and align them with the stars, you start to realize maybe the gods aren't in control of everything after all. Maybe it's the geometry. The gods wanted temples. They got them. But in the background, math was quietly sharpening its sword. The battlefield was being drawn, and soon the numbers would rebel. Picture yourself in ancient Babylon about 4,000 years ago. The air is hot, the streets are crowded, and towering ziggurats rise like giant Lego blocks against the desert sky. Priests in long robes are muttering chants, merchants are shouting over grain prices, and somewhere a scribe is hunched over a clay tablet, poking little wedge-shaped marks into wet mud with a reed stylus. Those wedge marks might look boring to us, but they were the seeds of something huge. The Babylonians had one of the most brilliant and unusual number systems in history. Instead of counting like we do today, in base 10 fingers, 10 digits, they used base 60. That's right, they were 60 people. Well, not literally, but their math was, why 60? Probably because 60 is ridiculously convenient. It has a ton of divisors. You can divide 60 by 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. Try that with 10 and you'll see why 60 was the VIP number of ancient math. In fact, we still live in the Babylonian world. Every time you glance at a clock, you're bowing to them. 60 minutes in an hour, 60 seconds in a minute, 360 degrees in a circle. That's all Babylonian math. They may be long gone, but their numbers are still ticking on your wristwatch. But the Babylonians weren't just obsessed with 60 because it was neat. They were trying to crack the code of the universe. And for them, the universe was the sky. Every night, the stars spread out above Mesopotamia like a glittering puzzle, and the priests believed the gods controlled it. But instead of just praying, the Babylonians started keeping records. Clay tablets filled with numbers, dates, and star positions. Night after night, year after year, they tracked the heavens. At first it looked like magic, but slowly patterns began to emerge. The moon disappeared and reappeared on schedule. The planets wandered across the sky in loops and zigzags, but even those loops repeated. Eclipses, once terrifying omens of divine anger, turned out to be predictable. Imagine the moment a Babylonian priest realized, wait, the gods aren't just tossing the sun into a cosmic eclipse whenever they feel like it. It happens every 18 years and 11 days. That's a cycle. That's math. This was dangerous knowledge. If you could predict the heavens, you weren't just a priest anymore. You were a code breaker. You knew the secret script of the gods, and the Babylonians leaned into it. They turned their astronomy into astrology. If you could predict when Mars would rise, you could also claim to predict when your king should go to war. If you knew when the moon would vanish, you could decide whether the crops would thrive or fail. Math became a political tool. Numbers weren't just numbers, they were power. Let me give you an example. The Babylonians could calculate something we now call the Pythagorean triples, sets of numbers like 3, 4, 5, which make right triangles. We usually give Pythagoras credit for discovering this in Greece, but the Babylonians had clay tablets with these triples scribbled down more than 1,000 years earlier. They weren't just gazing at stars, they were crunching geometry. And the way they did math was both clever and hilarious to us. Imagine doing long division on a clay tablet with a stick. No erasers, no backspace key. If you messed up, you just had to smush the whole tablet and start over. Yet somehow they figured out complex calculations we'd struggle with even today without a calculator. They even had methods for approximating square roots. There's a famous Babylonian tablet that gives an incredibly accurate value for the square root of 2, better than what your phone would display if you rounded it. These people weren't messing around. What's funny is that they never separated math from mysticism. For them, numbers were divine fingerprints. They didn't say, "Oh, we've discovered trigonometry." They said, "The gods have revealed a pattern in the stars." But whether they realized it or not, every clay tablet of star charts and every prediction of eclipses was another small crack in the wall of myth. The gods were supposed to be moody and unpredictable, but the math said otherwise. The math said the universe runs on rules. Of course, Babylonian math wasn't perfect. Their number system had one big flaw. They didn't have a real zero. They had a sort of placeholder symbol, but not a full concept of nothingness. So their numbers could get confusing. Imagine trying to figure out if 2-1 means 2 times 60 plus 1, or 2 times 60 squared plus 1. Without zero, it's like writing numbers in sloppy handwriting all the time. Still, for their purposes, tracking the sky, dividing land, planning temples, it worked. And here's something wild. The Babylonians were among the first to use math to predict the future, not in a vague fortune-teller way, but in a very specific, the next eclipse will happen on this date way. For a society drenched in myth, that must have felt like cheating. The gods were supposed to control the heavens, but suddenly math was saying, no, it's not about angry deities, it's about cycles, it's about numbers, and we can prove it. Think of the political drama. The king asks the priests, "Will the gods bless my campaign against that annoying neighbor city?" The priests consult their clay tablets, see that Mars is in a certain position, and say, "Yes, mighty king, the gods approve." But deep down, the priest knows it's not divine whispers, it's arithmetic. The priest is basically running the first version of Excel, but instead of pivot tables, he has a sack of clay tablets. So why do I call them code crackers? Because that's what they were doing. They were cracking the code of the universe. They didn't have telescopes, but they had patience, sharp eyes, and math. And patience plus math is basically the secret recipe for discovering the universe. They cracked the code of time. They cracked the code of cycles. They cracked the illusion that the heavens were just the random moods of divine beings. And that's how math started to rebel. Quietly, subtly. It didn't shout the gods are fake, it whispered, maybe the gods follow rules. And once you believe the gods follow rules, you're halfway to realizing maybe it's not the gods at all. Maybe it's just math. So the Babylonians gave us more than ziggurats and beer recipes. They gave us 60-minute hours, 360-degree circles, eclipse cycles, and the first crack in the divine armor. Every wedge pressed into clay was a step away from myth, and a step toward logic. And in the end, their numbers outlived their gods. You might not remember the names of Babylonian deities, but you definitely remember how to tell time. If you think fractions are annoying now, just be glad you weren't an ancient Egyptian scribe, because back then, fractions weren't just schoolwork. They were divine business. They were taxes, temple offerings, land divisions, and cosmic harmony all rolled into one, and the Egyptians had a truly weird way of dealing with them. Let's set the stage. Ancient Egypt was a land built around one giant moody river, the Nile. Every year the Nile flooded, spilling over the banks and soaking the fields with fertile mud. For the farmers this was a blessing. For the priests it was a miracle from the gods. For the scribes it was a nightmare of fractions. Here's why. When the Nile flooded, it erased property boundaries. Suddenly nobody knew whose field was whose. So the king would send out surveyors, ropes in hand, to remeasure the land. And those surveyors used math. They divided, subdivided, and assigned shares, in other words, fractions. If you got half a field or a quarter or 1/12, you'd better hope the math was right, or you might end up in an argument that even the gods couldn't fix. But the Egyptians didn't write fractions the way we do. No 2-3 or 5-8 for them. Instead, they insisted on writing every fraction as a sum of unique unit fractions, fractions with a numerator of 1. So instead of saying 2-3, they would write it as 1-2 plus 1-6. Instead of 3-4, they'd write 1-2 plus 1-4. Why? Because the gods apparently had a rule, thou shalt not put anything but 1 in the numerator. It sounds crazy, but they actually got very good at it. They even had fraction tables carved into papyrus to help them break down messy fractions into neat sums of unit fractions. Imagine being an Egyptian scribe flipping through a dusty papyrus that says, "Oh, you need to divide 5 loaves of bread among 10 workers. No problem, that's 1-3 plus 1-15, and the gods were apparently satisfied with this. Here's the funny part. Fractions were supposed to be divine gifts, but in reality they made humans smarter than the gods. Take the Nile again. For centuries, people thought the flooding was just a god's temper tantrum. One year too much water, the next too little. But then Egyptian scribes started tracking it. They noticed patterns, they measured flood levels, they compared harvest sizes, and soon they could predict the Nile with surprising accuracy. Suddenly, it wasn't the god Happy deciding the harvest. It was fractions. And this is where the Egyptians quietly mocked the gods. Not openly, of course. They weren't going to shout, "We don't need Happy anymore," from the rooftops. That would have been a short career move. Instead, they just kept their heads down and kept measuring. They knew that if you divided grain by fractions, stored it carefully, and planned for years of poor flooding, you were safe. The gods might look like they were in charge, but the fractions were doing the real work. Let's talk about the Rhind mathematical papyrus. This is one of the most famous math documents from ancient Egypt, dating to around 1650 BCE. It's basically a giant problem set written by a scribe named Amiz, and it's filled with fractions, word problems about dividing loaves of bread, distributing beer, measuring fields, the kind of stuff we do with calculators in 2 seconds. But Amiz did it all by hand, carefully breaking everything into unit fractions, as if the gods were watching over his shoulder. Here's an example problem from the papyrus. Divide 7 loaves among 10 men. Today we'd say, "Oh, that's 7/10 each." Simple. But Amos breaks it into 1-2 plus 1-5 plus 1-10 plus 1-20, 4 separate fractions, because apparently the gods hated shortcuts. Now, from a modern point of view, this seems horribly inefficient, but think about it. Breaking fractions into sums of unit parts might have actually been useful in a society where you were physically dividing things, like loaves of bread or jars of beer. If you had to share something, it's easier to say, "Give everyone 1/2, then add 1/5, then 1/20", than to explain 7/10 when nobody has a mental picture of what tenths look like. So maybe the gods weren't totally unreasonable after all. And of course, fractions weren't just about food, they were about taxes. And nothing motivates math quite like taxes. The pharaoh demanded a share of everything: grain, cattle, honey, linen. The scribes had to calculate those shares precisely. And if you underpaid, you weren't just cheating the government, you were cheating the gods themselves. Talk about pressure. But here's the twist. By using fractions, Egyptians slowly realized that the universe wasn't random. The Nile wasn't flooding out of divine mood swings. It was following seasonal patterns which could be measured, tracked, and predicted. Fractions turned a miracle into a calendar. They stripped the gods of their drama and replaced it with data. Let's zoom out. Fractions show up everywhere in Egyptian culture. In their art, proportions were carefully measured using grids. In their architecture, temple dimensions often reflected ratios tied to sacred numbers. Even their medicine had a kind of fractional math to it. Recipes for potions and remedies often called for specific fractional amounts of ingredients. Half of this herb, a quarter of that resin, a 16th of some weird ingredient like crocodile dung. Don't try that at home. So fractions, weird and messy as they were, became a bridge between magic and science. To the Egyptians, they were still gifts from Thoth, the god of wisdom, but in practice they were human tools. They let ordinary people survive the river, feed their families, and build monuments. The gods may have taken credit, but the math did the heavy lifting. And here's a fun thought. Imagine being an Egyptian farmer who notices the Nile flood levels every year. You keep track. Maybe on a piece of pottery, maybe just in your head. You notice that after so many years the floods repeat. You quietly realize this isn't random at all. You don't say anything out loud, you don't want to upset the priests, but deep down you're thinking, hey, maybe it's not the gods, maybe it's just fractions. That's the quiet rebellion of Egyptian math. It never shouted, it never picked fights, it just kept solving problems one fraction at a time, until the gods started looking less like masters of the world and more like mascots for things humans could already predict. So yes, Egyptian fractions were strange, clunky, and sometimes hilarious, but they were also revolutionary. They turned divine chaos into measurable order, they gave humans a tiny taste of control, and in doing so they chipped away at the power of the gods. Because once you can divide bread, predict the Nile, and measure the land, you don't need thunderbolts or divine tantrums to explain the world anymore. You just need math. Now we sail across the Mediterranean, to a place where math stopped being just bookkeeping for grain and temples, and started becoming, well, philosophy. Welcome to ancient Greece, home of olives, togas, and people who loved asking questions so much they invented an entire civilization around it. The Greeks looked at the Babylonians and Egyptians and thought, nice pyramids, cool ziggurats, love the fractions, but what does it all mean? Because if there's one thing the Greeks couldn't resist, it was asking why. Why does the Nile flood? Why do eclipses happen? Why does math actually work? They weren't content to just use numbers, they wanted to know the soul of numbers. And this is where we meet one of the most legendary and slightly eccentric math figures of all time, Pythagoras. Yes, the same Pythagoras whose theorem haunted your high school geometry class. But here's the thing, before he was an equation, Pythagoras was a philosopher, a mystic, and basically the leader of a math cult. The Pythagoreans believed that numbers were not just useful, they were divine. Everything in the universe, they said, was built from numbers. Harmony, beauty, music, even the movement of the heavens, it all boiled down to mathematics. Imagine treating math not as a subject, but as a religion. That's what they did. Here's a fun story. Pythagoras and his followers discovered that if you pluck a string on a lyre and divide its length into ratios like 1, 2, 2, 3, or 3, 4, the notes sound harmonious. Suddenly, they realized music wasn't random or magical. It was math you could hear. To them, this was proof the universe itself was built on numbers. The gods weren't just singing in the sky, they were obeying ratios. Of course, the Pythagoreans also had some strange habits. They believed in reincarnation, thought beans were evil, seriously they banned eating beans, and lived in a commune with strict rules. They were half math club, half monastery, half bizarre reality show. Imagine joining a cult where the initiation test is solving equations and refusing to eat hummus. That's Pythagoras. But weirdness aside, their core idea was revolutionary. Math wasn't just for counting sheep or dividing bread. It was the hidden language of reality. Numbers weren't human inventions. They were eternal truths waiting to be discovered. And once you believe that, you stop seeing math as a servant of the gods and start seeing it as a rival. Now, Pythagoras wasn't the only one pushing this idea. Greek thinkers loved mixing math with philosophy. Thales of Miletus, one of the earliest known Greek mathematicians, supposedly predicted a solar eclipse around 585 BCE. That blew everyone's minds, because here was a guy saying, the sun won't vanish because Helios is mad, it'll vanish on this date, right on schedule. He was basically the party pooper of Greek religion. Then came Anaximander, who tried to map the cosmos using geometry, and Plato, who famously said, "Let no one ignorant of geometry enter here," and plastered it above the entrance to his academy. Imagine being a student in ancient Athens, walking up to school and realizing you can't even get inside unless you know your shapes. That's how seriously they took math. For the Greeks, math wasn't just about practical use. It was about uncovering eternal, unchanging truths. The Babylonians looked at the stars and said, how do we predict this? The Egyptians looked at the Nile and said, how do we divide the land? The Greeks looked at a triangle and said, what is the nature of triangles? One culture was pragmatic, the other was philosophical, and that's why math in Greece evolved in such a different way. Let's talk about one of their favorite topics, geometry. To the Greeks, geometry was perfect because it didn't depend on messy real-world things. A triangle on paper could be perfect, even if no triangle in real life was. Geometry was pure, abstract, eternal. The gods might shift moods, humans might grow old, but a triangle's angles always added up to 180 degrees. It was eternal truth in a chaotic world. And of course, this made the Greeks just a little smug. They loved the idea that humans, mere mortals, could grasp truths that even the gods couldn't change. Zeus could throw thunderbolts all he wanted, but he couldn't make a right triangle break Pythagoras' theorem. That was math flexing its muscles. The Greeks also got philosophical about numbers themselves. Odd numbers were masculine, even numbers feminine. Prime numbers were mysterious and sacred. Numbers weren't just tools, they had personalities, like little characters in a cosmic drama. If Netflix had existed, the Pythagoreans would have binge-watched House of Primes. But with great curiosity came great problems. One of the biggest scandals in Greek math was the discovery of irrational numbers, numbers that couldn't be written as neat fractions. Legend says that when a Pythagorean named Hippasus proved that the square root of 2 was irrational, the others were so horrified they drowned him at sea, murdered over a number. That's how seriously they took their philosophy. Math wasn't just academic, it was dangerous knowledge. So Greek math was a strange mix. On the one hand, it was lofty philosophy, obsessed with eternal truths. On the other, it was cult-like, emotional, even mystical. They couldn't quite let go of the divine. They still thought numbers were magical, cosmic, spiritual. But by pushing math into the realm of philosophy, they gave it a new identity. No longer just a tool, now it was a worldview. And here's why that matters. Once you treat math as philosophy, you give it independence from religion. The Babylonians still wrapped numbers in astrology. The Egyptians still tied fractions to gods like Thoth. But the Greeks, they argued about math the way they argued about justice or beauty. They made math human, even when they thought it was divine. And that opened the door for something radical. Math could exist without gods at all. So in a way, Greek philosophy was math's adolescence. It was awkward, dramatic, full of strange ideas and strict diets. But it was also where math learned to stand on its own. From counting sheep to contemplating infinity, numbers had grown up. And somewhere in Athens, in a little courtyard filled with olive trees, a philosopher probably leaned back, smiled and whispered, "The universe doesn't need gods to explain itself. It just needs math." Look up at the night sky. Today you might see a quiet blanket of stars. Maybe the Milky Way if you're lucky enough to escape city lights. You know they're giant balls of burning gas, floating in space millions of light years away. You might even check an astronomy app on your phone and say, "Ah yes, that's Jupiter rising." But rewind a few thousand years. Back then, those dots weren't science. They were gods, monsters, and cosmic soap operas being played out across the heavens. For most of human history, the night sky was alive with stories. Orion wasn't just a cluster of stars, he was a mighty hunter. The Milky Way wasn't a galaxy, it was the milk of a goddess spilled across the sky. Eclipses were dragons devouring the sun, comets were omens of disaster, and shooting stars were messages from the gods. Every culture had its own script, its own cast of characters twinkling in the dark. But then, math came along with a big bucket of cold water, and little by little it started washing away the myths. Let's start with eclipses. Imagine living in the ancient world. It's the middle of the day, and suddenly the sun just vanishes. Darkness falls, birds go quiet, people panic. Of course you'd think the gods were furious. Maybe Helios parked his sun chariot early. Maybe some giant serpent took a bite out of the sky. Eclipses were pure terror. Enter the mathematicians. The Babylonians, as we saw earlier, started keeping records. And they noticed, hey, these eclipses aren't random, they come in cycles. Every 18 years or so, bam, another eclipse. That's not a moody god, that's math. By the time the Greeks got their hands on this knowledge, they could actually predict eclipses in advance. Imagine being an ancient Greek mathematician, standing in the marketplace and saying, "Don't panic everyone, the sun will vanish next Tuesday at lunch, but don't worry, it'll come back." That's not just math, that's sorcery. And speaking of Greeks, let's talk about Hipparchus. This guy was like the Sherlock Holmes of the sky. He compared centuries of star charts and noticed that the stars weren't staying put. They were slowly shifting, a phenomenon we now call precession. In other words, even the mighty constellations weren't eternal. They were moving. For cultures that thought constellations were divine paintings in the sky, this was a rude awakening. The stars weren't gods. They were part of a giant cosmic machine, ticking along with gears made of math. Then there was Aristarchus of Samos, who dropped a bombshell. Maybe the sun, not the earth, was the center of the universe. Revolutionary stuff. People didn't listen at the time, too scandalous. But the seed was planted. The sun wasn't a god steering a chariot. It was a ball of fire, huge and steady, around which everything else moved. That was the beginning of the end for star mythology. Let's not forget the astrologers. Astrology was big business in the ancient world. Kings hired astrologers to tell them when to go to war, when to plant crops, when to marry off their daughters. The stars were supposed to hold divine secrets about your destiny. But as astronomy got sharper, the predictions started looking suspicious. If you can predict Mars's orbit with geometry, do you really need a priest to tell you it means don't sign contracts on a Tuesday? The more math explained the sky, the more astrology started to look like a scam. And yet there's something kind of funny about this. Even as math was dismantling the myths didn't disappear overnight. People still wanted the stories. It's one thing to say eclipses happen every 18 years because of orbital mechanics. It's another thing to say a giant wolf swallowed the sun. Guess which version is more fun at a campfire? So for centuries both explanations coexisted. The farmers checked the priest's rituals, but they also peeked at the astronomers' charts just in case. Now here's a little anecdote that shows just how disruptive this was. In 585 BCE, a solar eclipse stopped a war. Two armies, the Lydians and the Medes, were in the middle of battle when the sky suddenly went dark. Everyone freaked out, assumed the gods were furious, and immediately stopped fighting. But somewhere in Greece, Thales of Miletus had predicted this eclipse ahead of time. Imagine the flex. Oh yeah, that wasn't Apollo's anger, that was just my math homework. That moment was a turning point. Math wasn't just observing the gods, it was stealing their script. Another key figure here is Ptolemy. His book, The Almagest, became the ultimate guide to the stars for over 1,000 years. He mapped planets, explained retrograde motion, and basically turned the heavens into geometry. Sure, he still thought Earth was the center, but his math was so good it didn't matter. For generations, priests, kings, and scholars trusted his numbers more than their myths. The stars weren't mysterious anymore. They were charts, tables, and circles. They were math problems waiting to be solved. And think about what that means. The night sky went from being a divine theatre to being a kind of giant clock. Predictable, mechanical, rule-based. The gods had lost one of their greatest weapons, the ability to scare humans with the unknown. Once you can predict the heavens stop being holy. But let's pause here, because as much as math was draining the magic, humans never fully gave it up. Even today, millions of people still read horoscopes, still look for meaning in star signs. Deep down, we kind of like the idea that the universe cares enough to send us messages. Math might explain the mechanics, but myth explains the emotions, and people crave both. Still, the balance was tipping. By the time the Greeks finished with the sky, the gods weren't in charge anymore. The stars didn't belong to Zeus or Apollo. They belonged to astronomers with dusty scrolls, measuring angles and scribbling numbers late into the night. The myths had lost their monopoly. So here's the takeaway. The stars lost their magic, not because humans stopped telling stories, but because math told a better one. A story that was precise, repeatable, testable. A story that could predict the future more reliably than omens and sacrifices. Once you've seen that story, it's hard to go back. The gods may have painted the sky with myths, but math came along with a ruler, a compass, and a smug grin, and quietly erased their power. Picture ancient Greece again. You've got philosophers arguing in the marketplace, poets reciting verses by the sea, and in the background, somewhere on a lonely hill, smoke rising from a mysterious temple. This is the Oracle of Delphi, the hotline to the gods, the place where kings, generals, and everyday citizens went to ask the big questions. Will we win the war? Should I get married? What should I do with my life? Now, the oracle was impressive. The priestess, called the Pythia, would sit over a crack in the earth, inhale strange fumes, and mutter cryptic phrases. Priests would translate those ramblings into something that sounded wise. People believed the words came straight from Apollo. Basically, it was the divine customer service desk of Greece. But while crowds were lining up to hear mystical riddles, something very different was happening in another corner of Greek society. In a dusty courtyard, a mathematician was crouched over a stick in a patch of sand, drawing lines, circles, and triangles. This wasn't prophecy, It wasn't divine smoke, it was geometry. And the answers that came out of those circles were often clearer and more reliable than anything the oracle ever said. That's where the tension lies. The oracle dealt in mystery, the geometer dealt in proof. One thrived on uncertainty, the other on certainty, and slowly people started noticing which one actually worked. Take Archimedes, for example. This guy was basically the Einstein of antiquity. He lived in the city of Syracuse, far from Delphi, and he had a brain that refused to stop tinkering. Legend says he invented war machines so powerful they could lift enemy ships out of the water, or set them on fire using mirrors. Now imagine how that looked to ordinary people. On one side you had priests mumbling about Apollo's will. On the other side you had Archimedes literally moving the world with a lever. Which one do you think seemed more godlike? And Archimedes had the attitude to match. He once bragged, "Give me a place to stand and I will move the earth." That's not humility. That's a man throwing shade at Zeus himself. The oracle could speak in riddles all day, but Archimedes could prove with geometry that his lever would actually work. Here's a funny story. During the Roman siege of Syracuse, Archimedes supposedly used giant mirrors to focus sunlight and set enemy ships ablaze. Historians argue whether this really happened, but imagine the scene. Roman sailors panic as their ships burst into flames. They think the gods have unleashed fire from the heavens. Meanwhile, Archimedes is on a hilltop with a smug grin, polishing his geometry-powered death ray. The oracle couldn't have dreamed up a better miracle. But Archimedes wasn't the only one. Greek geometers were solving problems that made divine riddles look silly. How do you measure the size of the earth? Eratosthenes did it with sticks and shadows. How do you predict the path of a planet? Hipparchus did it with trig tables. How do you prove the angles of a triangle always add to 180 degrees? Euclid did it with a pencil and a lot of patience. While the oracle kept people guessing, math was busy giving answers. Now, to be fair, the oracle had great marketing. People wanted mystery. They wanted to feel the gods cared about their personal struggles. No one was going to walk into a temple of geometry and ask, "Should I marry my cousin's daughter?" Math doesn't answer that. But math did something more dangerous. It started answering questions the oracle was supposed to own, like, why do eclipses happen? How do you build temples? How do you measure time? Those were once divine mysteries. Now they were math problems. And the Greeks loved to tell stories where oracles and logic clashed. One famous tale is about Croesus, the wealthy king of Lydia. He asked the oracle if he should go to war against Persia. The oracle replied, "If you cross the river, you will destroy a great empire." Croesus thought, "Perfect, I'll destroy Persia." He marched into battle, got crushed, and realized the oracle had meant his empire. Clever trick. The gods kept their reputation, but the advice was useless. Compare that to a geometer. If you build your bridge at this angle, it won't collapse. Which one would you rather trust? This is the shift happening in Greece. The oracle kept people in suspense. The geometer gave them clarity. And in a world growing tired of divine riddles, clarity was addictive. Another great example, Plato's Academy in Athens. Over the entrance, he supposedly inscribed, "Let no one ignorant of geometry enter here." That was his oracle. Not smoke, not riddles. Geometry. If you couldn't prove things with lines and circles, you didn't belong. That's how much weight math carried. But it wasn't just about proving theorems. Geometry had a kind of quiet power. A triangle didn't care about Apollo. A circle didn't need divine approval. These shapes obeyed laws no oracle could twist. They were eternal, unchanging, and above all, reliable. That reliability was math's weapon. The gods could be moody, the oracle could be vague, but geometry never lied. And yet, here's the irony. To many Greeks, geometry itself started to feel divine. Pythagoras' followers thought numbers were sacred truths. Plato said geometry was the language of the heavens. In their own way, the geometers became oracles too, but better ones. Their temple wasn't Delphi, it was the mind. Their smoke wasn't fumes from the earth. So when you picture the battlefield between myth and math, imagine this. On one side, a robed priestess swaying over fumes, muttering riddles from Apollo. On the other, Archimedes scribbling circles in sand, then using them to invent a weapon that terrifies an entire navy. Guess which side starts to look like it's actually in charge of reality. The oracle never truly disappeared. People always craved mystery, But after the geometers, the gods had competition. And for the first time in history, humans began to suspect that maybe the surest answers didn't come from smoke and riddles at all. Maybe they came from numbers. Infinity. Even today, it feels slippery, endless, bottomless, bigger than anything our brains want to handle. Now imagine being an ancient Greek 2,000 years ago, sitting in a courtyard in Athens, and someone casually drops the idea, what if numbers go on forever? Minds were blown, and not always in a good way. The Greeks loved order, they loved harmony, proportion, balance. Their gods reflected that: Zeus with his thunderbolts, Apollo with his music, Athena with her wisdom. Everything had its place. But infinity laughed at order. Infinity was chaos wrapped in numbers. It broke the rules of harmony, and for a culture obsessed with symmetry, that was terrifying. Let's rewind to the Pythagoreans, the math cult we met earlier. These guys thought numbers were the essence of reality. They loved whole numbers, neat ratios, musical harmony. To them, the universe was like a perfectly tuned lyre. Every string was in proportion, every note in balance. But then came the square root of 2. Legend has it that a Pythagorean named Hippasus discovered that the diagonal of a square couldn't be expressed as a neat fraction. It was irrational, an endless, messy number that never repeated, never fit into their tidy world view. This wasn't just inconvenient, it was blasphemy. If numbers were the language of the cosmos, what did it mean that one of them refused to play nice? Some stories say the Pythagoreans were so horrified they drowned Hippasus at sea, sacrificing him to keep the secret. Imagine being murdered because of geometry homework. That's how dangerous irrationality, and by extension infinity, felt to them. And it wasn't just irrationals. The idea of infinity itself made Greek philosophers squirm. Zeno of Elea came up with paradoxes to show how impossible infinity was, like Achilles and the tortoise. If Achilles gives a tortoise a head start and has to reach where the tortoise was, and then where it moved again, and again, he'll never catch it, because there are infinite steps. Obviously, in real life, Achilles would blow past the tortoise. But Zeno's paradox made infinity look absurd. It was a headache disguised as philosophy. Aristotle, one of the most influential thinkers in history, hated the idea of actual infinity. He made a distinction. Potential infinity was fine. You can always keep counting, 1, 2, 3 forever. But actual infinity, the idea that infinite things could exist all at once? Absolutely not. For Aristotle, infinity was like inviting chaos to dinner. The gods loved order, and infinity wasn't order. Infinity was divine anarchy. But here's where it gets interesting. The Greeks couldn't avoid infinity. Every time they tried to push it away, it came sneaking back. Geometry kept hinting at it. Divide a line in half, then in half again, then again, and again. You never run out of divisions. That's infinity hiding in your ruler. Look up at the stars. How far does the cosmos go? No one could say. That's infinity glaring at you from the night sky. So what did they do? They treated infinity like a rude guest. They acknowledged it existed, but they didn't invite it to the dinner table. They built their math on finite numbers, tidy ratios, logical proofs. Infinity was left outside the door, knocking quietly, waiting for another era. But infinity never really leaves. It lurked in paradoxes, in irrationals, in geometry, and it whispered a dangerous idea. Maybe the universe isn't neat. Maybe it isn't harmonious. Maybe it's endless, messy, and impossible to fully grasp. For the Greeks, that was deeply offensive, because if infinity ruled, then the gods didn't. And yet the seed was planted. The idea of infinity stuck in human thought like a burr. Later, in medieval times, theologians would wrestle with the idea of God as infinite. In the Renaissance, mathematicians like Galileo would puzzle over infinite sets. Centuries later, Cantor would shock the world by proving there are different sizes of infinity. But the first time humans stumbled into it, the reaction was horror. I like to imagine a Pythagorean sitting in the dark, staring at a chalkboard, whispering, "Numbers go on forever," and feeling the same fear we feel when we look into deep space. Infinity isn't comforting, it's humbling. It says, no matter how smart you are, no matter how many sheep you count or temples you build, there's always more, always beyond, always endless. And that was offensive to the divine order of the ancient world, because gods liked boundaries. They liked being in control. Infinity couldn't be controlled. Infinity laughed at control. It was bigger than Zeus, bigger than Apollo, bigger than the entire Greek pantheon. Infinity didn't need myths. Infinity was its own myth. So when the Greeks tiptoed around infinity, they weren't just avoiding a math problem, they were protecting their worldview. Because once you let infinity in, the neat harmony of the universe cracks. And through that crack, something new shines. A vision of reality far bigger than the gods themselves. Infinity offended the divine, but it also foreshadowed math's ultimate victory, because one day humans would stop fearing it and start embracing it. And when that happened, the gods never stood a chance. Every great movement needs its book. Religions have scriptures, nations have constitutions, fans of fantasy novels have giant trilogies that weigh as much as a brick. For mathematics, that book was The Elements by Euclid, written around 300 BCE in Alexandria. It became the math Bible, not just for a few years, not just for a century, for 2,000 years. Think about that, a book so good, so clear, so annoyingly logical, that it was used from the days of the pharaohs all the way until the 19th century. If you studied geometry in school and had to prove that triangles are congruent or that parallel lines behave themselves, you were basically studying Euclid. He's the guy who made geometry official. But who was Euclid? Honestly, we don't know much. He's a bit of a ghost. Most of what we know comes from stories told centuries later. What we do know is that he lived in Alexandria, a city that was basically the Silicon Valley of the ancient world. Huge library, scholars from everywhere, a melting pot of knowledge, perfect place for a math wizard to sit down and organize the universe. And that's exactly what Euclid did. The Elements isn't just a math textbook. It's a masterpiece of structure. Instead of messy notes or random discoveries, Euclid started with simple definitions. A point is that which has no part. A line is length without breadth. Then he laid down axioms, self-evident truths, like, if two things are equal to a third thing, then they're equal to each other. And from there he built everything step by step, proof after proof, theorem after theorem, until you had the full cathedral of geometry. This was math with the discipline of a religion. You didn't just say, I think triangles have these properties. You proved it, logically, from the ground up. It was airtight. It was beautiful. It was, in a way, sacred. Now imagine the contrast. While oracles were spouting riddles, Euclid was writing a book where nothing was left to mystery. While myths explained the world with stories of gods, Euclid explained it with proofs. And his proofs didn't change with the seasons or depend on Apollo's mood. They were eternal. If something was true in Euclid's geometry, it was true forever. This was radical. In a world where people believed divine powers controlled everything, Euclid handed humans something indestructible, a framework of certainty. You didn't need sacrifices or prayers to know a square's diagonals are equal. You just needed a pencil, a straight edge, and Euclid's book. Here's a fun anecdote. A student once asked Euclid what they would gain from learning geometry. Euclid told his assistant to give the boy a coin, because he must profit from what he learns. In other words, if you're here for money, go away. Geometry isn't about profit, it's about truth. That kind of pure dedication made math feel more like philosophy, even spirituality, than just numbers. And that's why I call the Elements sacred. For centuries, people treated it almost like holy scripture. It was copied, studied, translated into Arabic, Latin, and countless other languages. Scholars carried it like a torch through the Middle Ages. When universities first appeared in Europe, the Elements was on the syllabus. When scientists like Newton or Galileo needed a foundation, they leaned on Euclid. Think about the impact. If you were a medieval student, you might go to theology class to learn about God, then go to geometry class to learn about Euclid. In a way, it was like attending two churches, one of faith, one of logic, and slowly the Church of Logic started winning converts. But Euclid didn't just give humans a toolbox. He gave them confidence. If you can prove things with certainty, then maybe the universe isn't chaos. Maybe it's knowable. Maybe it follows rules that humans, not gods, can understand. That's a dangerous thought in a world run by priests. And let's be honest, Euclid's system is addictive. Once you taste the clarity of a logical proof, it's hard to go back to fuzzy answers. Imagine being a Greek student at the time, torn between the Oracle of Delphi saying, "Your future is cloudy," and Euclid saying, "Here is a 47-step proof that will always be true. Who are you going to trust?" Of course, Euclid wasn't flashy like Archimedes with his war machines or like Pythagoras with his bean-hating cult. He was quiet, methodical, almost invisible. But his impact was bigger than any weapon or prophecy. His book gave humanity a permanent weapon against ignorance, logic. Here's the kicker. The Elements lasted longer than almost any religious text in terms of practical use. Generations of students groaned over it. Philosophers admired it. Even Abraham Lincoln, thousands of years later, studied Euclid by candlelight to sharpen his reasoning skills. That's right, the same book that trained Greek students trained an American president. So why call it sacred? Because in its own way, it replaced the gods. People once turned to Apollo for answers about the universe. After Euclid, they could turn to geometry. Proof was the new prophecy. Triangles were the new temples. The gods gave humans myths. Euclid gave them certainty. And certainty is a kind of power even Zeus couldn't control. Let's do a thought experiment. You're living in the 3rd century BCE, in ancient Greece. You've never seen a globe, never flown in an aeroplane, never scrolled through satellite images on Google Earth. All you know is what your eyes show you. The ground feels flat, the horizon stretches endlessly, and if you walk far enough, maybe you'll fall off the edge. At least that's what some people thought. But not Eratosthenes. This man looked at the Earth and thought, yeah, I can measure that. And here's the crazy part. He did. With no satellites, no planes, no drones, not even a hot air balloon. Just shadows, sticks, and a good deal of patience. Eratosthenes was a librarian in Alexandria. And not just any librarian. He was head librarian at the Great Library, the biggest collection of knowledge in the ancient world. If you loved books and scrolls, this was heaven. And Eratosthenes loved knowledge. He was a geographer, a mathematician, a poet, and apparently a guy who got very distracted by shadows. One day, he read about a city far south of Alexandria called Syene, modern-day Aswan. There, at noon on the summer solstice, the sun shone directly overhead. How did people know? Because deep wells in Syene lit up all the way to the bottom. No shadow. The sun was straight above. But in Alexandria, on the very same day and time, sticks and columns still cast shadows. That tiny detail, shadows in one city, no shadows in another, set off fireworks in Eratosthenes' brain. He realized something brilliant. If the Earth were flat, the sun's rays would hit everywhere the same. No shadows in Syene would mean no shadows in Alexandria too. But the shadows were different. That could only mean one thing. The Earth was curved. So Eratosthenes grabbed a stick technically called a gnomon and stuck it in the ground in Alexandria at noon on the solstice. He measured the angle of the shadow about 7.2 degrees, then he did some quick math. If 7.2 degrees of Earth's surface gave that shadow, and a full circle is 360 degrees, then the distance between Alexandria and Syene must be 7.2360 of the Earth's circumference. Multiply the distance between the two cities by 50, and boom, you get the size of the whole planet. Now, how did he know the distance? He asked travelers, camel caravans, people who paced it out. They told him it was about 5,000 stadia, the Greek unit of length. Multiply that by 50, and you get 250,000 stadia. Depending on how you convert stadia into modern units, that's somewhere between 39,000 and 46,000 kilometers. The actual circumference of Earth, about 40,075 kilometers. In other words, Eratosthenes nailed it, with sticks and shadows, 2,000 years before satellites. Think about how insane that is. While most people were still arguing whether the Earth was flat or round, this librarian casually pulled out his protractor and measured the planet. And he was so accurate that his estimate could pass for a decent high school answer today. Now imagine telling your neighbor about this in 240 BCE. Hey, I just measured the Earth. They'd probably laugh in your face, then go back to worrying about whether Zeus was angry about the harvest. But Eratosthenes had something better than divine approval. He had proof. And he didn't stop there. He also came up with a system of latitude and longitude, drew some of the earliest maps of the world, and even tried to calculate the tilt of the Earth's axis. The man was a one-person Google Earth, long before Earth was even fully mapped. Here's the funny part. His nickname was Beta, meaning second best. People called him that because he was supposedly never the very best at anything. Not the best mathematician, not the best philosopher, not the best poet, always second place. But tell me this, if you can measure the Earth with a stick, you're not second best in my book. You're legendary. The story of Eratosthenes is more than just a neat math trick. It's a turning point in the war between myth and numbers. For centuries, the size of the Earth had been a mystery wrapped in divine stories. Some said the Earth floated on water. Some said it was held up by a giant turtle. Others thought it was infinite. But Eratosthenes said, no, it's a sphere, and I can measure it. Not with sacrifices, not with prayers, but with geometry. And that's a quiet revolution. Because once you prove you can measure the Earth, you start asking what else can we measure? The sun, the moon, the distance to the stars. Suddenly the universe looks less like the playground of gods and more like a giant math problem waiting to be solved. But here's my favorite part of the story. Eratosthenes didn't shout it from the rooftops. He didn't demand that everyone abandon the gods. He just wrote it down, calmly, methodically, like a true librarian. His book on geography laid out his methods, and centuries later, other scholars built on it. That's how revolutions happen. Not always with fanfare, but with quiet confidence. Of course, not everyone believed him right away. Some people clung to myths. Some said his measurements were wrong. But slowly his methods spread, and by the time explorers like Columbus set sail, they were using ideas that traced back to Eratosthenes. Ironically, Columbus actually underestimated the size of the Earth, which is why he thought he'd reached Asia when he bumped into the Americas. If only he'd trusted Beta the librarian, history might have looked very different. So what's the lesson here? Sometimes the greatest challenges to the gods come not from thunderous speeches or dramatic battles, but from a man with a stick, a shadow, and a little bit of geometry. Eratosthenes didn't just measure the Earth. He measured humanity's growing confidence that the universe was understandable, that it wasn't chaos, that it wasn't divine mystery, it was math. The gods once held the Earth in their myths. Eratosthenes held it in his equations. And honestly, I think that's even more impressive. Let's head back to the night sky. For most people in the ancient world, the heavens were the stage for divine drama. Gods riding chariots, monsters lurking in constellations, omens written in the stars. But for one man, Hipparchus, the sky wasn't a theatre of gods. It was a giant math puzzle waiting to be solved. Hipparchus lived around the 2nd century BCE, and if Eratosthenes was the Google Earth of the ancient world, Hipparchus was its Google sky. He was the first great astronomer who said, "Okay, enough with the myths. Let's actually measure this thing." So what did he do? Pretty much everything. He built the first trigonometric table, discovered precession, the slow wobble of Earth's axis, made the first real star catalogue, and invented a system that was basically the ancestor of latitude and longitude for the heavens. In other words, he turned the gods' glittery ceiling into a set of coordinates. Let's start with trigonometry. I know. The word alone might give you flashbacks to high school nightmares, sine, cosine, tangent. But back then, this was revolutionary. Hipparchus realized that if you could measure angles in a triangle, you could use that to calculate distances to things in the sky. He compiled a table of chords, the old-school version of sine functions, and with that, you could do serious astronomy. Imagine the excitement. Instead of saying, Mars is wandering across the heavens, a sign of war, you could say, Mars is moving along this predictable path at this angle with this timing. The gods lost another job. But Hipparchus didn't stop there. He made a star catalogue with around 850 stars, noting their positions and brightness. This was the first known attempt to actually map the heavens with scientific accuracy. Before him, stars were just pretty patterns, like constellations shaped into animals and heroes. After him, stars had data, numbers, coordinates. He was turning the sky into a spreadsheet. Now, the really mind-blowing part. Precession. While comparing his star charts to older Babylonian records, Hipparchus noticed something odd. The stars weren't staying put. Over centuries, they shifted slightly. The equinox, the point where the sun crosses the celestial equator, was moving backward through the zodiac. Today, we call this precession, caused by the slow wobble of Earth's axis, like a spinning top. Think about that discovery. For most people, the stars were eternal, fixed, the perfect backdrop painted by the gods. But Hipparchus showed they weren't fixed at all. The heavens themselves were moving, slowly but surely, according to mathematical rules. That's like pulling the rug out from under an entire worldview. The gods' eternal canvas wasn't eternal, it was physics. Of course, not everyone appreciated this. Myths are comforting. They give you heroes, monsters, meaning, numbers. Numbers just sit there on clay tablets. But Hipparchus didn't care. He was obsessed with accuracy. He wanted to know exactly where the stars were, how they moved, and why. He wasn't reading omens, he was writing equations. Here's a fun anecdote. Hipparchus also figured out how to measure the distance to the moon. He noticed that during a solar eclipse, the moon's shadow on Earth had a certain size. By comparing observations from different places, he estimated the moon was about 30 Earth diameters away. The actual number is about 60, so he was off by a factor of 2. But come on, he did this with no telescope, no computer, just geometry and guts. That's impressive. And the irony, while priests were still claiming eclipses were signs of divine anger, Hipparchus was using those same eclipses as measuring sticks. For him, the gods' tantrums were math problems. Hipparchus also contributed to geography. He proposed a grid system using latitude and longitude, which later influenced Ptolemy. Imagine traveling with maps before GPS and realizing this Greek guy had already sketched out a coordinate system 2,000 years earlier. Every time you use Google Maps today, you're walking in Hipparchus's footsteps. But here's what fascinates me. Hipparchus wasn't flashy. He didn't write dramatic stories or brag like Archimedes. He was more like a quiet coder, working late nights under the stars, building the framework that everyone else would later use. While others told myths about constellations, he was saying, yes, that's a scorpion, but here's its exact right ascension and declination. It's like everyone else was writing fan fiction, and he was writing the user manual. And maybe that's why his work mattered so much. Because once the stars had coordinates, they stopped being mysterious. Once you can put numbers on them, they belong to math, not myth. Not myth. Of course, Hipparchus didn't live to see the full consequences. He probably never imagined satellites, telescopes, or astronauts. But the seed he planted was enormous. He took the gods' grandest stage, the night sky, and replaced it with a grid. And grids, once drawn, don't go away. Think about it. The gods once controlled the heavens. Then Hipparchus pulled out his chalk, drew some triangles, and said, "Actually, I've got this." And from then on, the stars belonged less to Apollo and more to trigonometry. It's a quiet victory. No thunderbolts, no divine duels. Just a man, a sky, and some numbers. But in the long war between myth and math, this was one of the biggest battles won. If Greek math had a rock star, his name was Archimedes. Born in the city of Syracuse around the 3rd century BCE, he wasn't just a mathematician. He was an engineer, inventor, philosopher, and part-time destroyer of Roman navies. The man was basically the Elon Musk of antiquity, except with fewer tweets and more catapults. Archimedes is famous for saying, "Give me a place to stand, and I will move the earth." That wasn't empty bragging. He truly believed that with the right lever, math could do anything. While Zeus hurled thunderbolts from Mount Olympus, Archimedes hurled actual boulders at invading ships. Guess which one caused more immediate problems? Let's start with his machines. During the Roman siege of Syracuse, Archimedes supposedly turned the city into a math-powered fortress. He designed catapults that could fling massive stones farther than anyone thought possible. He invented cranes that could lift ships right out of the water, leaving Roman sailors flailing like ants in a bathtub. Some stories even claim he built giant mirrors to focus sunlight and set ships on fire. Historians debate that one, but imagine the panic if you were a Roman soldier and suddenly your ship started smoking under the midday sun. Divine wrath? Nope, just Archimedes with a geometry experiment. And it wasn't only about war. He also built peaceful devices, like the Archimedean screw, a machine for raising water from low ground to high. Farmers used it to irrigate fields. Sailors used it to pump water out of ships. It was simple, clever, and incredibly effective. To the average Greek, that probably looked like magic. But Archimedes wasn't praying to Poseidon. He was applying ratios, spirals, and leverage. Now, what made Archimedes special wasn't just his gadgets. It was how he saw the world. For him, math wasn't an abstract game. It was power. If you understood geometry, you could build machines that rivaled the gods. You didn't need thunderbolts or divine favors. You just needed a lever, a pulley, and some patience. And the man had humor too. There's the famous bathtub story. Archimedes was trying to figure out how to measure the purity of a crown, whether it was pure gold or mixed with cheaper metals. He stepped into a bath, noticed the water level rise, and realized the displacement could reveal the crown's volume. He jumped out, ran naked through the streets of Syracuse shouting "Eureka!" which means "I have found it." The gods might have demanded sacrifices for wisdom. Archimedes found it in his bathtub. This was math openly mocking the divine. The Greeks once believed Poseidon controlled the seas, but Archimedes could calculate buoyancy and design ships that floated because of physics, not because Poseidon was in a good mood. Zeus could strike with lightning, but Archimedes could burn ships with mirrors. Hermes might carry messages, but Archimedes' inventions carried water uphill. Every gadget was a reminder that math could achieve what myths only promised. Of course, Archimedes wasn't invincible. When the Romans finally conquered Syracuse, despite all his machines, Archimedes was killed, supposedly against orders, because the Romans admired his genius. One story says he was drawing circles in the sand when a soldier ran him through. Imagine dying mid-equation, but even in death his legend grew. The Romans may have taken Syracuse, but they couldn't conquer his ideas. His writings survived, and for centuries scholars treated them with awe. Archimedes explored areas and volumes of shapes, anticipated calculus, and proved theorems with a precision that inspired generations. But he wasn't just about abstract math. He showed that math could touch the real world, that it could build, destroy, and transform. Think about the symbolism. The gods were supposed to control storms, earthquakes, and war. Then along comes Archimedes, a mortal with chalk and ropes, building machines that could toss enemy ships around like toys. For ordinary people, that must have been unsettling. Was he blessed by the gods? Or was he proving you didn't need gods at all? Even today, Archimedes feels larger than life. His lever quote still inspires engineers. His screw is still used in irrigation. His principle of buoyancy is taught in every science classroom. And every time you pull out a calculator, you're echoing his belief that math is the key to unlocking the universe. So what's the Archimedes moment? It's the realization that math can imitate, replace, and even surpass divine power. Zeus had thunder, Archimedes had science, and in the long run, Archimedes won. Because the gods' miracles were myths. Archimedes' miracles were machines. If the Greeks were the dreamers of mathematics, the Romans were the doers. The Greeks wanted proofs, harmony, and eternal truths. The Romans wanted aqueducts, roads, and a functioning empire. They weren't sitting around asking, what is the essence of triangles? They were asking, how do we get water into this city before everyone dies of thirst? And honestly, that's where math shines. Not in temples or ivory towers, but in the dust and sweat of construction sites. The Romans mastered practical math, and in doing so, they quietly pushed their gods out of business. Let's start with their aqueducts. Rome was famous for its water systems. Giant bridges carrying streams of clean water across valleys and into cities. These aqueducts weren't built by praying to Neptune or sacrificing goats to river spirits. They were built with surveying, geometry, and a very good sense of slope. Roman engineers knew that water would flow downhill if given just the right gradient. Too steep, and the channel would erode. Too shallow, and the water would stall. So they perfected gentle slopes, sometimes only a few centimeters drop per 100 meters. That's not divine inspiration, that's math. Imagine being a Roman citizen, standing under a towering aqueduct. You see water flowing smoothly, day after day. The priests might say Neptune blessed the city, but deep down you start thinking, actually I think it's those engineers with their measuring rods. Quietly, math was stealing Neptune's thunder. And then there were the roads. The Roman road system stretched across Europe, the Middle East and North Africa. Straight, solid, efficient. They used surveying tools like the grommer, which allowed them to line up roads with astonishing precision. These weren't paths wandering around mountains because a god told them to. They were grids, cutting through the landscape with mathematical stubbornness. The gods might have drawn rivers and hills, but the Romans drew straighter lines, and lines beat myths every time. Roman military strategy was also dripping with math. Legion formations were carefully calculated for maximum efficiency. Forts were laid out in perfect squares, like military spreadsheets made of stone. The gods of war might have been Mars and Bellona, but it was geometry that won battles. Taxes. Oh yes, the Romans were masters of fractions too. They needed to keep track of land, grain, livestock and wealth across a massive empire. Their accountants, let's call them the unsung heroes of math, divided and subdivided everything into shares, quotas and percentages. If you owed 1/10 of your harvest, that wasn't just a religious offering, it was a precise tax calculation. Jupiter didn't come knocking for your grain, the math did. And we can't forget architecture. The Colosseum, bridges, baths, temples, they weren't built by chanting hymns, they were built by applying ratios, arches, and engineering tricks. The famous Roman arch wasn't divine revelation, it was the math of distributing weight. That simple idea let them build structures so strong that many are still standing 2,000 years later. That's a better miracle than most gods ever managed. What's fascinating is that the Romans still paid lip service to their gods. They built temples, held ceremonies, sacrificed animals. But when push came to shove, they trusted engineers more than priests. If a bridge collapsed, you didn't blame Jupiter. You blamed the builder. That's a cultural shift right there. The gods became figureheads, mascots, decorations for temples, while math quietly ran the empire. There's a great irony in this. The Romans worshipped a whole pantheon of gods, but their empire survived not because of divine blessings, but because of surveyors with ropes, builders with compasses, and generals with strategy tables. Religion gave Rome its identity, math gave it running water. And which one do you think mattered more on a hot summer day? Here's a little anecdote. When Roman engineers built aqueducts, they sometimes tunneled through hills from both sides at once. Imagine digging a tunnel through solid rock with no modern tools, hoping both ends would meet in the middle. And more often than not, they did. How? Careful measurement. Math. The gods didn't line up those tunnels, the surveyors did. And when they got it right, you'd better believe the crowd cheered louder for the engineers than for Jupiter. But Romans were practical in another way too. They weren't obsessed with the purity of math like the Greeks were. They didn't care if it was elegant or philosophically beautiful. They just wanted it to work. Need a formula for the volume of a grain silo? Great. Need to calculate how many bricks to build a wall? Perfect. Need to schedule supplies for a legion on the march? Let's crunch the numbers. The gods didn't handle logistics, math did. And that pragmatism left a legacy. Even today, when you walk on a Roman road, drink from a Roman aqueduct, or sit in a Roman amphitheatre, you're seeing math's quiet victory over myth. The gods may have had temples, but math had infrastructure, and infrastructure lasts longer. Now, of course, Romans still like to claim divine favour. Victories in war were always dedicated to Mars. Prosperity was thanks to Jupiter, but in practice, generals consulted maps, not oracles. Architects consulted ratios, not omens. The gods took the credit, math did the work. So if the Greeks gave math its soul, the Romans gave it its paycheck. They proved that numbers weren't just for philosophers, they were for building empires. And once you see math delivering water to your house every day, it's hard to keep believing it's only the gods who keep you alive. In the end, Roman practical math was like a quiet rebellion. The empire kept bowing to the gods in ceremonies, but the real power lay in surveyors' rods, drafting compasses and counting tables. And that's how math kept winning. One aqueduct, one road, one arch at a time. Numbers have always carried a kind of glow. Long before people were scribbling formulas in notebooks, certain numbers already felt like they had cosmic importance. 3, 7, 12. We've seen how they became sacred in myth and ritual. But as time went on, something funny happened. Those same magic numbers started slipping out of temples and into laboratories. They went from mystical symbols to scientific tools. The gods may have given them sparkle, but math gave them substance. Take pi, for example. Pi has been lurking around humanity for thousands of years. It's the ratio of a circle's circumference to its diameter. Sounds simple enough, right? But it's not neat. It's messy, irrational, endless. The Egyptians had rough approximations for pi, using it to design pyramids. The Babylonians had their own estimates, sneaking it into their calculations. To them it was mystical. Circles were divine, eternal, perfect. Of course, the ratio of a circle would be sacred. But over time, pi stopped being just a symbol. The Greeks dug into it with more precision, trying to trap it with polygons. Archimedes famously calculated pi by inscribing and circumscribing polygons around a circle, showing it was between 3.1408 and 3.1429. That might not sound exciting, but in his time, it was revolutionary. Pi wasn't just divine mystery anymore. It was a number you could pin down, sharpen, and use. The gods gave you circles. Archimedes gave you decimals. Then there's the golden ratio, often called phi, about 1.618. This number has been praised as the fingerprint of beauty itself. The ancient Greeks thought it showed up in art and architecture. Later, Renaissance artists like Leonardo da Vinci wove it into their paintings. Nature seemed to love it too. Spirals in shells, branching in trees, even the proportions of the human body. To mystics, phi was proof of divine design. But mathematicians started looking closer. The golden ratio wasn't magic. It was geometry, algebra, and self-replicating patterns. What looked like the hand of a god was really the hand of mathematics. And then we have Fibonacci numbers. Start with 1, then add the previous number to get the next. 1, 1, 2, 3, 5, 8, 13, on and on. Suddenly you start spotting these numbers everywhere. Pine cones, sunflower seeds, rabbit populations. Fibonacci looked like a cosmic code. For centuries, people treated it as mystical, a sign that the universe was speaking in numbers. But eventually mathematicians showed it wasn't magic at all. It was just the way things grow when each stage depends on the previous one. Math was sneaking into biology, disguising itself as magic. The pattern is clear. What started as superstition turned into science. Numbers that were once used to impress worshippers in temples became the foundation for discoveries in physics, biology, and engineering. It's as if math was slowly stripping off the costume of divinity, saying, "No, I'm not magic, I'm real, and I'm everywhere." But here's the funny part. Even as these numbers turned scientific, people never stopped treating them as magical. Pi Day is still celebrated like a holiday. The golden ratio still gets called the key to beauty in YouTube videos and coffee table books. Fibonacci spirals are still plastered on posters about the mysteries of life. We can't help it, we love the idea that numbers are mystical, even when science has explained them. And maybe that's okay. Because for ancient people, calling these numbers divine was their way of recognizing that math had power. They didn't have the language of algebra or calculus, but they could sense that numbers shaped the world. Calling them magic was the best compliment they could give. Think about it. A farmer in ancient Greece didn't care about the golden ratio as an algebraic expression, but he saw that spirals in shells matched spirals in plants. He saw harmony in music, proportions in temples, patterns in the stars. That harmony felt divine. Today, we just call it mathematics. Here's a little anecdote. Kepler, the 17th century astronomer, was obsessed with the golden ratio and Fibonacci spirals. He thought they were keys to the architecture of the cosmos. He even called the golden ratio one of the precious jewels of geometry. For him, it was both science and poetry. He was right, in a way. Those numbers really do appear everywhere, but instead of being proof of divine secrets, they turned out to be proof of natural laws. Pi 5 Fibonacci. These numbers were once treated like gods themselves, and yet over time math took them off the altar and put them in textbooks. The magic didn't vanish though, it just changed form, because when you realize that the same number guiding the spiral of a galaxy also appears in the petals of a flower, it still feels miraculous. Only now the miracle belongs to math, not myth. So the story of magic numbers is really the story of transition. The gods used them as decorations, symbols of mystery. Humans turned them into equations, tools of discovery. The sparkle never left. They just started shining for different reasons. And that's how math works. It doesn't destroy wonder, it redefines it. What used to be divine becomes scientific. What used to be mystical becomes measurable. And every time that happens, the gods lose another little piece of their power. Because once you can calculate pi, once you can prove the golden ratio, once you can model Fibonacci growth, you don't need to say the gods did it anymore. You can just smile, point at the equation, and whisper, math did it. If geometry was the proud Greek invention, algebra was the gift of the Islamic Golden Age, and if geometry was about drawing shapes in sand and proving eternal truths, Algebra was about solving problems, step by step, with a kind of quiet logic that made myths look clumsy by comparison. Algebra didn't just calculate, it organized thought. It showed that problems which once felt mystical could be cracked open by symbols. The word algebra itself comes from the Arabic word al-jabab, meaning reunion of broken parts. Already that sounds magical, doesn't it? Like putting broken pottery back together. But in the hands of mathematicians, it wasn't about pottery. It was about numbers, equations, unknowns, mysteries that could finally be solved without asking the gods for hints. Let's go back to Baghdad, around the 9th century, during a time when the city was buzzing with scholars. In the House of Wisdom, an incredible research center, sat a man named al-Khwarizmi. If Euclid was the father of geometry, al-Khwarizmi was the father of algebra. He wrote a book called the Compendious Book on Calculation by Completion and Balancing. Doesn't exactly scream bestseller, but it changed the world. In this book, al-Khwarizmi laid out methods for solving quadratic equations, things like x squared plus 10x 39. He explained how to complete the square, a technique students still learn today. He gave clear step-by-step instructions for handling unknowns, and that was revolutionary. Instead of guessing or hoping for divine inspiration, you followed a method, you balanced, you completed, and you found the answer. Now, compare this to how people used to solve problems. Let's say you needed to divide land after a flood, or calculate inheritance between siblings, or figure out how many bricks a temple needed. Before algebra, you might appeal to tradition, ritual, or even an oracle. After algebra, you just wrote an equation. One side equals the other. Balance it. Done. This was more than math. It was a mindset shift. Algebra taught people that problems weren't mysteries to be feared. They were puzzles to be solved. That idea undermined mythical thinking. The gods thrived on mystery. Algebra thrived on clarity. And here's the kicker. Al-Khwarizmi's work spread far and wide, translated into Latin in medieval Europe. It shaped Western mathematics. His name even gave us the word algorithm. So every time you scroll through your phone, every time Google sorts your search results, every time Netflix recommends a movie, you're whispering his legacy. Algorithms are just algebra on steroids. But back in his day, algebra was already breaking myths. For example, Babylonian astrologers once claimed the gods controlled inheritance and wealth distribution, but algebra showed you could calculate inheritance fairly, using equations, without consulting omens. Priests used to interpret divine signs to divide land. Algebra said, nope, here's the formula. Goodbye superstition, hello balance sheet. The power of algebra is that it abstracts. Geometry is tied to shapes you can draw. Fractions are tied to things you can cut and share. But algebra is pure structure. An unknown x doesn't represent a loaf of bread or a field of wheat. It can represent anything. It's a placeholder for the unknown, a way of capturing uncertainty in symbols. And once you can represent uncertainty with math, you no longer need myths to explain it. Let me give you a picture. Imagine a farmer who once believed the gods decided how much grain he'd harvest. Now, thanks to algebra, he realizes he can model it. If one field produces 5x bushels and another produces 3x, then total yield is 8x. It's not magic, it's an equation, and once you think that way, the gods lose ground. Algebra also unlocked new kinds of knowledge. With equations, you could solve for roots, calculate areas, predict unknowns. You could plan ahead in ways myths never allowed. Suddenly, merchants had tools to calculate profits, engineers could design better structures, and astronomers could model planetary motion. That's not divine revelation, it's systematic thinking. Of course, people didn't stop treating numbers as mystical. Superstition is stubborn. Even in the Islamic Golden Age, numerology was popular. Some thought certain numbers had magical properties, blessings or curses. But algebra kept cutting through the noise. It didn't care about lucky sevens or divine threes. It cared about balance. It cared about solutions. And maybe that's why algebra was so disruptive. It was boring compared to myth. No thunderbolts, no oracles, no epic stories, just step-by-step logic. But boring has power, because boring works. If you want water in your city, you need engineers, not prophets. If you want fair inheritance, you need equations, not omens. Algebra was boring enough to outlast the gods. Over time, algebra became the backbone of everything. Science, engineering, finance, algorithms. It replaced divine guesswork with universal rules, and with each equation solved, myths looked a little less convincing. So how did algebra break mythical thinking? By showing that unknowns weren't unknowable, by proving that mysteries could be solved without priests, sacrifices, or divine drama. It turned the terrifying chaos of life into symbols on a page, and once you see life as an equation, it's hard to go back to blaming Zeus for your problems. Algebra didn't shout its victory, it just quietly balanced the scales. And in the long war between myth and math, that was enough. So far, the story has felt like a steady march of victory. Math rises, myths crumble. Geometry replaces oracles. Astronomy predicts eclipses. Algebra balances the books. It almost feels inevitable, like numbers were always destined to win. But history isn't that smooth. The gods didn't go quietly, they fought back. And when I say the gods, I don't mean Zeus literally throwing lightning bolts at mathematicians. I mean superstition, religion, tradition, all the forces of culture that didn't want to let go of their monopoly on truth. Math was gaining ground, but the old ways weren't about to vanish without a fight. Take the Middle Ages in Europe. For centuries, much of Greek knowledge was forgotten in the West. Libraries burned, empires fell, and math was shoved into monasteries where monks copied manuscripts by candlelight. To most people, the world went back to being ruled by divine mystery. Eclipses were once again omens, plagues were punishments, and numbers belonged more to magic than to science. But when scholars tried to bring math back into the conversation, they often met resistance. A great example is heliocentrism, the idea that the Earth revolves around the Sun. It was actually proposed way back in antiquity by Aristarchus of Samos, but nobody wanted to hear it. The gods had written the script. Earth was the center, humans were special, everything else revolved around us. When Copernicus revived the idea in the 1500s, it looked like pure blasphemy. And then came Galileo. With his telescope, he saw moons orbiting Jupiter, proof that not everything circled Earth. He wrote about it, argued about it, and poked the bear of tradition one too many times. The gods, or rather their representatives in the church, struck back. Galileo was dragged before the Inquisition, forced to recant, and spent his last years under house arrest. Imagine being punished not for insulting a god, but for pointing your telescope in the right direction. That's how desperate the old worldview was to hold on. But it wasn't just astronomy. Even basic math met suspicion. In some cultures, zero was seen as dangerous. Nothingness, emptiness, that smelled like heresy. When Fibonacci introduced Hindu-Arabic numerals to Europe in the 13th century, merchants loved them, but governments resisted. Some cities even banned their use because they thought they were untrustworthy, easier to forge than Roman numerals. Picture a medieval accountant sneaking zeros into his ledger like contraband. Superstition was also alive and well in everyday life. Numbers still carried magical weight. 13 was unlucky, 7 was lucky, 12 was holy. People believed in numerology, astrology, and all sorts of mystical patterns. Even when algebra was spreading, horoscopes still had a bigger audience. The gods may have been losing the war, but they were winning the popularity contest. And that's the thing, myths are sticky. They appeal to the heart, not the head. Math gives you proofs, but myths give you stories, and people love stories. It's much easier to believe a comet means doom than to memorize orbital mechanics. So even as mathematicians chipped away at superstition, myths kept coming back, like weeds in a garden. There's another angle here, power. Myths gave priests and rulers authority. If you could claim to speak for the gods, you held people's lives in your hands. Math threatened that. If you could predict an eclipse without divine permission, suddenly the priest wasn't the only expert in town. If you could divide inheritance with algebra, the oracle wasn't needed. That made math dangerous, not just intellectually but politically, and politics hits back. But here's what's fascinating. The gods' counterattack actually slowed math's victory enough to make it stronger in the long run. Every time math was suppressed, it went underground, got preserved by scholars in Baghdad, monasteries in Ireland, or merchants in Italy. When it resurfaced, it was sharper, more organized, and harder to ignore. You can ban zero for a century, but eventually people realize zero is too useful to live without. You can put Galileo under house arrest, but you can't uninvent the telescope. And here's a fun anecdote. When Kepler, one of the great astronomers of the 17th century, discovered the laws of planetary motion, he was torn between myth and math. On the one hand, he wanted to fit orbits into mystical shapes, like perfect circles or platonic solids. On the other, the data screamed ellipses. In the end, math won, but it shows how tempting it was, even for geniuses, to cling to divine order. So yes, the gods fought back. Through bans, trials, superstition, and stubborn tradition, they tried to hold on to the heavens to keep numbers under lock and key. But math had a secret weapon. It worked. Bridges stayed standing, aqueducts kept flowing, planets kept moving in predictable ways. Myths could inspire, but math could deliver. And when the two went head to head, the one with results always won. The gods slowed math down, but they couldn't stop it. Because at the end of the day, thunderbolts are impressive, but running water is better. For thousands of years, people looked to the heavens, temples, and oracles for answers. The gods were the ones who knew everything. Or at least that's what people thought. But as math slowly chipped away at their power, something strange happened. We didn't get rid of gods entirely. We built new ones. And this time, they weren't carved in stone or painted in myths. They were written in numbers. Think about it. Once math proved it could predict eclipses, measure the Earth, map the stars, and balance inheritances, it started to look like the ultimate authority. Priests could say the gods control the heavens, but astronomers could prove exactly when the next eclipse would happen. Who looked more powerful? Suddenly, math wasn't just a tool. It was treated with the same reverence once reserved for the divine. In a way, numbers themselves became godlike. Infinity, for instance, terrified the Greeks because it felt endless, beyond human comprehension, almost divine. Later mathematicians embraced it, but still spoke about it in hushed tones. Zero too. For centuries, zero was feared and resisted because it represented nothingness, the void. But once adopted, it became one of the most powerful concepts in human history. You can't do modern math without it. Zero went from taboo to sacred, like a forbidden deity suddenly worshipped by everyone. And then there's the language of math itself. Equations started to look like spells. Take Newton's laws of motion. Suddenly, 3 neat formulas could describe everything from apples falling to planets orbiting. To an ordinary person, that looked like wizardry. The gods once made the heavens move. Now a few lines of algebra could explain it all. This reverence for math wasn't limited to scientists. Philosophers got swept up in it too. Descartes, for example, tried to base philosophy itself on mathematical certainty. I think, therefore I am was his attempt to find a proof as solid as geometry. Kant believed math revealed deep truths about how we perceive reality. Even poets and artists became fascinated by mathematical beauty. The golden ratio in paintings, Fibonacci spirals in nature. Math stopped being just useful. It became awe-inspiring. And here's the twist. By dethroning the old gods, math accidentally became a new one. Think about how we talk about it even today. We say the numbers don't lie. We treat statistics as gospel. We design economies, governments, and even personal lives around data. The gods used to decide fate. Now algorithms do. Swipe right, swipe left, recommended movies, credit scores, all of it decided by math humming in the background. This isn't new. Even in the Renaissance, people treated math with near-religious respect. Galileo called mathematics the language in which God has written the universe. Kepler described his laws of planetary motion as reading the mind of God. These scientists were pulling power away from myth, but they couldn't resist putting math on a divine pedestal of its own. Math was too precise, too universal, too powerful not to feel sacred. Of course, this new god didn't look like Zeus with a beard. It was quieter, invisible. It lived in proofs, ratios, and patterns. But it had the same qualities people once ascribed to the divine. Eternal, unchanging, beyond human whim. 2 + 2 is 4 yesterday, today, and forever. That's immortality right there. And like any god, math inspired both devotion and fear. Devotion, because it worked miracles. Bridges that stood for centuries, machines that flew, medicine that healed. Fear, because it also revealed unsettling truths. Infinity, chaos, probability. All concepts that make us feel small. In some ways, math was more frightening than Zeus. Zeus might throw a thunderbolt if he was angry, but infinity reminds you that you are a speck in an endless cosmos. That's existential dread, courtesy of numbers. But here's the thing. Humans seem wired to worship something bigger than themselves. When the old myths collapsed, math slid right into that role, not because it demanded sacrifices or built temples, but because it offered what the gods once promised: order, meaning, and a sense that the universe makes sense. So the birth of this new kind of god wasn't a dramatic event. No lightning bolt, no burning bush, just centuries of scribes, philosophers and scientists quietly replacing divine stories with equations. And eventually people looked up at the heavens and realized the gods may be silent, but the numbers are speaking loud and clear. The gods ruled with myth. Math ruled with proof. And proof, it turns out, was the stronger faith. So here we are, thousands of years after thunder was explained as Zeus's tantrum, after eclipses were dragon bites out of the sun, after temples were built to sacred numbers, the gods faded, the myths unraveled, and math patiently, step by step, took their place. But in a twist of irony, math didn't just replace mythology, it became a kind of mythology itself. Think about how we treat numbers today. People check their horoscopes, sure, but more often they check their bank account balance. They don't ask an oracle for advice, they ask their fitness tracker or their stock market app. In the ancient world, priests read the entrails of animals to divine the future. Today, algorithms read your browsing history to predict what shoes you'll buy next. Different rituals, same hunger for guidance. And just like old myths, math now has its own mysteries. Take quantum mechanics, equations that say particles can be in two places at once, numbers that describe probabilities instead of certainties. For most people, that sounds more bizarre than any myth about gods turning into swans. Or consider infinity. Mathematicians proved there are different sizes of infinity, an idea so strange it makes you feel like you're back in a temple hearing a riddle from a priestess. We also treat equations with reverence. Einstein's EMC quadrate is practically a holy symbol. Even people who don't understand it put it on posters, mugs, and t-shirts. It's the modern equivalent of carving sacred inscriptions into temple walls. And pi. Every year we celebrate Pi Day, eating pie and chanting digits like monks reciting scripture. Tell me that isn't ritual. And then there are algorithms. Invisible, omnipresent, shaping our lives in ways we barely notice. They decide which videos we see, which news we read, which routes we drive, even who we date. Ancient people believed in fate, woven by gods like the fates spinning their thread. Today, fate is written in recommendation engines and machine learning. If Zeus was watching you from Olympus, now it's your phone screen. The gods may be gone, but math is watching. The irony is beautiful. Math started as scratches on clay tablets, a way to count sheep and jars of beer. It grew into geometry, astronomy, algebra. It dethroned myths, measured the earth, mapped the heavens, and now it's wrapped itself in mystery again. Only instead of temples we have data centers. Instead of oracles we have algorithms. Instead of priests we have programmers. But maybe that's okay. Humans seem to need myths, not just for answers but for wonder. Math gives us both. It tells us why the planets move, how bridges stay standing, why epidemics spread. But it also leaves us with awe, infinity, chaos theory, the strange beauty of fractals, the eerie precision of prime numbers. These things make us feel small and amazed, just like myths once did. And just like old myths, math has its heroes. Archimedes, Euclid, Al-Khwarizmi, Newton, Einstein, their names are passed down like demigods, each one adding to the story. They aren't riding chariots across the sky, but their theorems and discoveries feel just as epic. So, did math defeat the gods? In one sense, yes. It took their jobs. No god decides when the sun rises anymore. That's orbital mechanics. No god determines the flood of a river. That's hydrology. No god controls fate. That's probability, statistics, and data science. But in another sense, math didn't kill mythology. It became mythology. It became the story we tell ourselves about the universe. The story written not in poetry, but in equations. The story not carved into temple walls, but into computer code. And maybe that's the ultimate twist. Humans didn't get rid of gods. We just changed their form. Once they were Zeus and Apollo. Now they're Piety and Infinity. Once they sat on Olympus. Now they live in formulas, algorithms, and the quiet certainty that 2 + 2 will always equal 4. So the next time you check your bank account, glance at your GPS, or celebrate Pi Day with a slice of pie, Remember, you're participating in the new mythology. Not the mythology of gods and thunderbolts, but the mythology of math. Calm, logical, and if you listen closely, still just as full of wonder. Because in the end, we didn't destroy the divine, we just rewrote it, and the new language of the gods is numbers.